Hey guys, and welcome to this next trigonometry video all about obtuse angles and exact values. So we're starting to hit some of the more advanced levels of trigonometry, particularly for year 10. Now we're talking about obtuse angles and exact values. So this is going to be a bit of an introduction to the unit circle, a little bit of an idea of how the unit circle is going to work, and how we can use these angles and trig ratios in different ways. So we have over here, we have a unit circle. So this here is the unit circle. And we will be exploring the unit circle a little bit more at different times. Now what you can see in the unit circle, we have a radius of 1. That's really important. We tend to keep the unit circle with a radius of 1, so the hypotenuse will be the value of 1 the whole way around. And then we hit 1, minus 1, minus 1, and 1 as we're traveling. Now, our direction of travel when we're using the unit circle is anti-clockwise. Now, a few videos ago, we looked at bearings, and bearings went clockwise from the vertical. Here, we're actually going to go anti-clockwise from the horizontal. So we actually start, put it as a different color maybe. We want to start at that X. We want to start on the horizontal and the positive side of horizontal. And we're going to head that away. So we're going to head around anti-clockwise. Now if we look at our unit circle, we can redefine our three ratios. We have sine theta. Now sine theta is still the opposite over hypotenuse. All right, that hasn't changed, okay? But if you have a look at the unit circle, if we want the opposite side, so let's pick a color for the opposite. Let's go green for opposite. All right, that's the opposite side is green. I'll pop that little bit around the box. All right. That's going to be a change in y. That's going to be the y value, that vertical. It's going to be the change in y. So this is just another way it relates to linear relationships as well. So this is the change in y, or the rise. So we have y over 1, because 1 is the hypotenuse. Okay, y over 1, well that's just going to be y. So sine of theta in the unit circle is just whatever that change of value of y is. Now cos theta is still adjacent over hypotenuse. Okay, we're still adjacent over hypotenuse. And if you have a squiz at our diagram over here, that's going to be our vertical, which is our change in x. So that's our change in x. So this is actually going to be x over 1, which is just x, which leads us very nicely into our tan theta, because our tan theta is still the opposite over the adjacent, which is going to be y over x, which is what we were talking about a few videos ago when we linked it to linear relationships and gradient. And that's just going to be sine theta over cos theta. Okay, so sine theta is always the y coordinate of whatever point we're looking at. Cos theta will be the x coordinate of whatever we're looking at. And then tan is going to be the y divided by the x, which is just sine theta over cos theta. And that's what we have written there. And this is going to be true, doesn't matter what point we are on that unit circle. We could be all the way down here, still going to work. Okay? Now, one little thing that I want to point out about the unit circle, I'm going to pop it over in this bit. In quadrant 1, and I'm going to use the purple pen here, all of our values are going to be positive. Now, slightly different for the rest of the unit circle. This side, which is quadrant 2, this side, only sine is positive. Really important to remember as we're exploring a couple of little bits and pieces around our unit circle and around our values. Okay, so we use that unit circle and we call it a unit circle because the hypotenuse is the value of 1. Alright, so that line, that hypotenuse, has a value of 1, so 1 unit. Okay, so that's why we're calling it that unit circle. Now we said before, sine theta is the y coordinate, cos theta is the x coordinate, and tan theta is y over x. We've already looked at that. But the other thing that we need to look at is the idea of supplementary angles. So you may remember that supplementary angles sum to 180 degrees. Okay, so that's why we're just sticking with those first two quadrants for now. We just want to worry about the 180 degrees. And remember I said in the first quadrant, all of our bits and pieces are positive. In our second quadrant, only the sine stuff is positive. So if it has sine in front of it, it'll be positive. If it has cos in front of it in that second quadrant, or tan, it'll be negative. Okay. So for supplementary angles, theta and 180 minus theta are supplementary. Okay, so 180 minus theta and theta, they are supplementary. If we look at a couple of quick examples, if I take cos of 145, then its supplementary will be minus cos 35. Okay, because we're going from the other direction. So cos 145, that's in one quadrant, minus cos in the other quadrant. Sine is going to be positive no matter which way around you go, but tan will be positive and negative. So if I had, for example, sine of 180 minus theta, or yeah, so 180 minus theta, it would just equal sine theta. Okay, they need to add together. So let's see that in numbers as well. So such as sine 145 degrees, well, that's going to be sine of 35 degrees. So remember that sine is going to be positive both ways, especially if we're in those first two quadrants. Sine will be positive. Okay. Now, a couple of little extra bits to be remembering. Alright, 4 acute angles, which is what I was saying before. Alright, so these guys are going to be acute angles of 0 is less than theta, which is less than 90, which is one of the ways we write it. Alright, all of those values are going to be positive. For the obtuse angles, which is going to be 90 degrees less than theta, which is less than 180 degrees, that's when you're going to get only sine being theta. Now this is a big mishmash of wonderful things. Let's jump into the exact values part of this video. Exact values. Now, this is going to be a little bit interesting for you because these are our special triangles. Special triangles, and they are found with Pythagoras. Okay, found with Pythagoras. What we're saying, okay, is that if we have sides of 1, so both sides of 1, we've got angles of 45, hypotenuse is going to be the square root of 2. If we have a side of 1 and a hypotenuse of 2, we've got our 30, 60 angles. The other side is going to be the square root of 3. So all of that can be found using Pythagoras. And I'm just going to pop in a couple of examples. So if I wanted, say, sine of 45 in our special triangle, well, that will be 1, because it doesn't matter which way around, it's going to be 1 over the square root of 2. 1 over the square root of 2. Okay. Or it could even be square root of 2 over 2. Depends on the angles that you're looking at. So if I was to go over on the other side and go sine of 30 degrees, okay, this one is going to be 1 over 2. Alright, so this is all coming out of our exact values of our special triangles. Sine of 60 degrees, okay, is actually going to be the square root of 3 over 2. If I wanted tan of 45, alright, tan being opposite over adjacent, well, it doesn't matter which way around we go, it's going to be 1 over 1, which obviously equals 1. Okay, so it just works out from there. Okay, now on your handout I have included the table. So this is a table of exact values. It's going to give you all the information that you need for those few sets of angle values. So if we have 0 degrees, we're going to have 0, 1 and 0. If we have 30 degrees, it's a half, root 3 over 2, root 3 over 3. Now that has coming about because of different things with surds that we haven't actually touched on just yet, but it will make sense eventually. Real quick, we're going to jump into the examples. We need to choose an obtuse angle to complete each statement. So, remembering supplementary angles. Supplementary angles. So, sine of 30 Well, it's 180 minus 30. So it's going to be 150. Okay, so that's just what we're doing. Sine over 180 minus 30. Alright, it's going to be the negative of, don't need that bracket, cos 180 minus 57, alright, which is going to be cos, or minus cos 123. And then tan, it has its same deal there. We're going to be tan of 81 equals minus tan of 180 minus 81. But if you've done the maths already, it'll be minus tan of 99. Real quick and easy. All right, last three little bits. Let's find the exact values of the following. Alright, exact values of the following. We've got cos of 60 degrees. So if we go back up to our triangles. Alright, cos of 60 degrees. Well, there's 60. We want root 3 over 2. So actually, we don't want root 3 over 2 because root 3 would be the opposite side. So if we draw in our little thing, we have 1, 60, 30, 2, root 3. Cos of 60 degrees will equal 1 over 2. So our exact value is a half. Sine of 50. Well, that's going to be the same as sine of 30 because they are supplementary. Alright, sine 30 is also 1 over 2 based on that information. And then tan of 135, well, that's going to be the same as minus tan because it's on the opposite side of 45 because it's 180 minus 135. Alright, so we're going to be minus 10. But if we use our other triangle, which is our 45-degree triangle, alright, and we just have our 1 over 1. We don't really need the minus 10 in there anymore. So it's going to be minus 1 over 1, which is just minus 1. This stuff's going to take some practice, so please get that practice in. Do the questions that are there and provided for you. Good luck with those questions, and I will see you in the next video.